According to the Five Kingdoms system, among the animals in Kingdom Animalia, the animals without a vertebral column are classified into 8 phyla: Porifera, Coelenterata, Platyhelminths, Nemathelminths, Annelida, Arthropoda, Mollusca, and Echinodermata. Animals with a notochord and vertebral column are classified under the phylum Chordata. Hence, there are altogether 9 phyla in the Kingdom Animalia. Phyla in Kingdom Animalia: Porifera, Coelenterata, Platyhelminths, Nemathelminths, Annelida, Arthropoda, Mollusca, Echinodermata, Chordata. So let's start comparative difference between these various phylum. First, meaning. Have you ever wondered why these creatures are called porifera? The name is actually derived from the Latin words porus, meaning pore, and ferae, meaning to bear. Put simply, it means a paw bearing. If you look closely at a sponge, whether it's Spongilla, a common bath sponge, or Euspongia, you'll notice their entire bodies are covered in thousands of tiny holes or pores. Next up is Coelenterata. This name comes from the Greek words koilos, meaning hollow, and entron, meaning intestine or cavity. Essentially, it translates to a hollow-bodied. They have an internal hollow cavity in their body which is called coelenterans. That is the reason why they are called Coelenterata. If you see the hydra, they have hollow body cavity. For example, hydra, jellyfish, and coral. The term platyhelminths is derived from the Greek words platies, meaning flat, and helminths, meaning worm. Consequently, the name literally translates to flatworms, referring to their characteristic flattened body shape. If you see the body of tapeworms, it is completely flat, and so does the other. For example, tapeworm, blood fluke, and liver fluke. The term nemathelminths is derived from the Greek words nema, meaning thread, and helminths, meaning worm. Consequently, the name translates to threadworms. Unlike the flat bodies of platyhelminths, the members of this phylum possess a cylindrical, elongated, and unsegmented body that appears circular in a transverse cross-section, which is why they are commonly known as roundworms. If you observe the body of a roundworm, it is completely cylindrical and tapers toward both ends. Examples include Ascaris, also known as roundworm, hookworm, and pinworm. The term annelida comes from the Latin word annellus, which means little ring. It is used because these worms have bodies made up of many repeating ring-like segments joined together. While platyhelminths are flat and nemathelminths are smooth and round, annelida look like they are identical rings, which is known as segmented body. If you look closely at an earthworm, you can see these little rings that is covering its entire body. The term arthropoda is derived from the Greek words arthron, meaning joint, and podos, meaning foot. Consequently, the name refers to the most distinctive feature of this group, jointed legs. If you observe a crab, you can clearly see that its legs are made up of several distinct, connected sections. Examples of arthropods include crabs and lobsters, insects, spiders, The term mollusca is derived from the Latin word mollus, which means soft. This name refers to their bodies, which are typically very soft and lack an internal skeleton. If you look at a common garden snail, you can see its soft body protected by a hard, coiled shell. Examples include snails and slugs, octopus, cuttlefish, oysters, squids. The term echinodermata is derived from the Greek words echinos, meaning spiny, or hedgehog, and derma, meaning skin. This name perfectly describes their most famous feature, a body covered in spiny skin. Starfish, sea urchins, sea cucumbers, The term chordata is derived from the Greek word chord, which means string or chord. This name refers to the notochord, a flexible, rod-like structure that runs along the length of their body, providing support and acting as a precursor to the backbone in vertebrates. Unlike the invertebrates we have looked at so far, chordates are defined by this central string that supports their body structure. If you look at the spine of a fish, a bird, or a human, you are looking at the evolved version of that original notochord. Examples include fish, birds, mammals. So open your copy, write down the phyla and their meaning. In this session, we will perform a comparative study of 8 invertebrate phyla. We will discuss chordata in a separate class. First, on the basis of body layer and body organization. Body layer. These are the germ or body layers named as ectoderm, mesoderm, and endoderm. Diploblastic, 2 germ or body layers. These 2 layers are ectoderm and endoderm. Triploblastic, 3 germ or body layers, and these 3 layers are ectoderm, mesoderm, and endoderm. If we compare these invertebrates, the first 2 phyla, Porifera and Coelenterata, are diploblastic, meaning they consist of 2 germ layers. In contrast, all the remaining phyla are triploblastic, meaning they consist of 3 germ layers. Similarly, regarding body organization, Porifera exhibits cellular grade organization, while Coelenterata exhibits tissue grade organization. From platyhelminths onward, the organisms consist of organ-level organization, and from nemathelminths onward, they possess an organ system level of organization.
So now let's talk about the body symmetry. Let's try to understand the meaning first. Asymmetric. Organisms with asymmetry lack any defined pattern or symmetry. No matter how you divide the body through its center, you will never get 2 equal or mirror image halves. Similarly, radial asymmetry. Organisms with radial symmetry have body parts arranged around a central axis, like the spokes of a wheel. You can cut the organism along several vertical planes, passing through the center to produce mirror image halves. Bilateral symmetry. Bilateral symmetry is characterized by a body plan that can be divided into 2 identical left and right mirror image halves only along a single vertical plane, the sagittal plane. Example, humans, insects. So now let's see the comparative table to understand this.